Okay, so this is the second half of 3.4. So here we want to find the zeros and multiplicities for this function, and we're going to use the graph to help us figure that out. Okay, so notice there's an x-intercept right here at 2. Okay, so, and notice that it's bouncing. So because of the bounce, that means x minus 2 squared is a factor. Okay, right? So x equals 2 is a 0, and it shows up twice. So we're gonna do synthetic division with 2 in this function, and we're gonna do it twice. Okay, so right, drop the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 6 plus 4 is negative 2. 2 times negative 2 is negative 4. Negative 8 plus negative 4 is negative 12. And then 2 times negative 2 is negative 24. Okay, so we got our zero remainder as we expected. So we're going to take this cubic polynomial and divide it one more time by 2 again, right? Because we know 2 is a 0 showing up twice in this function. Okay, so we're going to do some synthetic division again. Same process. All right, and we see that we get a zero remainder again. So we're going to take this quadratic, x squared plus 4x plus 6, and we try to factor it. We can't, because factors of 6 that add up to 4 don't exist. So we have to use the quadratic formula to figure out those zeros. So this is the quadratic formula for what's in green. Okay, and we're going to simplify it. So we're going to simplify what's under the radical. So 4 squared, 16. 16 minus 24 is negative 8 over 2. Okay, now we're going to try to simplify root 8. So root 8, right, y'all might have learned this in geometry, doing a factor tree to pull out pairs. So root 8 simplifies to 2 root 2. But since it's negative 8, it'll be plus or minus 2i root 2 over 2. Okay, and then we try to simplify it if we can. Simplify it, so we can simplify it, because remember, this is really like two fractions happening right here. Okay, so this simplifies to negative 2 plus or minus I root 2. So those are the other two zeros. And it says write the function as linear factors. So we're going to have f of x equals, x minus 2 squared. We saw that from the graph. And then we've got x minus negative 2 plus or minus, but we'll just do them separately. So plus I root 2. So this is one factor. And then the other factor is x minus negative 2 minus I root 2 as the other factor. Okay, 6 says, okay, if g of x is a polynomial with zeros of 6, multiplicity of 1, a negative 4, multiplicity of 2, 6i, 3 plus 4i, what is the minimum degree? Okay, now, if with these complex zeros, we know they come in pairs. So negative 6i and 3 minus 4i should also exist by the conjugate zeros theorem. So we just count up how many zeros we have. So we've got 1, 2, 3, 4, 5, 6, 7. So there's 7 zeros here that we can account for. So the minimum degree of this function has to be 7 based off what we know. Okay, and we'll stop there.